Okay, let's have a look at problem 33, search in rotated sorted array. So for this problem, we are going to give a binary search solution. So we'll see that the core of this problem in using binary search is the search range update. So that's all about it. So first, I'll go through the statement of the problem, and then we will use a picture to demonstrate the search range update. Then we write the code. So first, let's look at the statement of the problem. So there is an integer array called nums sorted in ascending order, so with distinct values. So prior to being passed to a function, this nums is possibly rotated at an unknown pivotal index, so that the resulting array is something like this: nums k up to nums n-1, then start from nums0 to nums k-1. Notice that both nums0 and nums k-1 is less than nums k. In other words, so this part, the numbers are all greater than the numbers in this part. So that's an example. For example, this part, so from 7 drops to 0, then to 2, and 2 is less than 4. So the problem is that given the array nums after possible rotation and an integer target, return the index of target if it is in the nums. Otherwise, we return -1. So here another requirement is about time complexity. So you want to write an algorithm with logarithm runtime complexity. So that's the main statement of the problem. So let's look at the examples, so which is easy to analyze. For example, here, so the target is 0, the return is index 4. And in example 2, the target is 3, and the return is -1, because 3 does not belong to this. So example 3, target is 0, again does not exist, so return -1. So let's look at the constraints quickly. So the first one is about the range of length, so it's less or equal than 5,000. Anyway, so the problem itself requires a logarithm runtime complexity. The second one is about the range of each element in nums. So this one is also important. It's all the values are unique. And the fourth one is that the nums is possibly rotated or just not rotated. Both are possible. So with that said, let's look at the method we are going to use. So here, what we want to use actually is just a little bit further step than the standard binary search. So the key is how do we do the shrinkage. So in other words, how to update the search range. So we will demonstrate this picture with a demonstration. So basically, if we initialize the left or right, then we get the middle. So if the middle equals the target, so we just need to return the middle index. That's it. Otherwise, we need to update the search range. So in standard binary search, we either go left or go right. But here, because the array are possibly rotated, so we need to analyze how we update. So here actually are two cases, but in both cases, this part is all higher than this part in value. Similarly here. So in case 1, actually, the mid, so the nums m is greater than the nums l. In other words, the middle value is greater or equal than the left value. So in this case, if target is in the range L and M, so we need to search to the left of M. So another case is that, so the nums M is less or equal than the right end number. So definitely it will also less than all the part up to here, right? So in this case, if target does not let in the range from M to R, we also need to search in the left. So that's the key. So in both the case 1 and case 2, we need to search in the range left to m. In all other cases, we need to search to the right. That's the core point of this problem. So now with that said, let's write the code. We just follow the picture definition demonstration. So first, the hyperfunction. I just want to make it isolated to demonstrate the idea. So here we will define a hyperfunction. Let's take two arguments. One is L, one is R. So the two indices. So first, a special case. If L is greater than R, so we want to treat this as a special case as -1. So then, if it's not this case, we're going to get an m equals left plus right into division by 2. Then we do check as in the standard binary search. So if nums m equals target, then we are okay, right? In this case, we just need to return m. So that's about the routine. So now it's the update search range. So that's the key point of this problem in this solution. So I will follow the two cases here. Let's write like this. So if nums L, so it's less or equal than target and less than nums M. So in this case, this is corresponding to case 1 here. And in the second case, let me just copy this one. This is the one case. Let me put a parenthesis here. Or let's put another. So this case. So that's corresponding to case 2 in the picture. So if this were the case, basically we need to search to the left of m. So in other words, we are going to return helper L m minus 1. This corresponding to set R equals m minus 1. So all the other cases, so we are going to search to the right of m. We are going to return helper, so m plus 1 up to R. So that's the hyperfunction. So with that side, let me do the return, call and return. So what we need to call actually just the hyperfunction. So hyper. So the input is 0 and the last index of nums. In other words, length minus 1. So this about the solution. So again, let me emphasize. So these are the two cases that the search range update is to the left of m, right? So in all the other cases, the search range is to the right. So that's the only difference actually from the standard binary search. In the standard binary search, so once we do the comparison, so we just need to compare if nums m is greater than target or not. If it's greater, so we are going to search in the right of m, otherwise left, right? So with that said, let me test some special cases, then test a generic case. Yeah, this path is example 1. Let's try example 2. So the target is 3. Invalid tab case. Let me. Here's common. Yeah, it passes example 2. So now let's try example 3. It's 1 and 0. So it should return -1. So with that said, let's do another final test for generic case. Yeah, it passes the generic case. So yeah, with that said, that's about it. So to summarize, so this is a little bit further effort from the standard binary search when we do the search range update. I think that's sort of the core point of the problem. Thank you very much.